Alrighty, hello everybody. I hope you're having a good day. It is e-learning day today. It's pretty cold out. I have to walk my dog Harvey every once in a while, and let me tell you, that's not a fun experience. First off, I'm going to apologize for the flashing lights. Unfortunately, I couldn't figure out how to get Subway Surfer to take up half the screen, so we're going to have to settle for this. Anyway, let's go ahead and have notes open to 8.4a. We're going to go ahead and talk about some proportionality theorems. We are going to take a second day over this, so when we when we do come back from the e-learning day, we will be talking about some proportionality theorems again. So let's go ahead and let's hop into it. So, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths, right? So these sides here are proportional, meaning this. If we have DE and AC are parallel, remember that's what these arrows mean right here, right? So if we have that the mid segment of a triangle, so here's what they did, right? Here's how we get a mid segment. Draw a triangle, and then draw a line through that triangle. There's your mid-segment, right? Now, if this mid-segment is parallel to this bottom side, then that means that this side of this small triangle, BD, over the same side or the similar or corresponding side of the larger triangle, which is AB, well, that's equal to the ratio of these other sides over here. So BE, which is of the smaller triangle again. And then the larger triangle for this side over here, that would be BC. So that larger side right there. Right, so now the converse, that just is the reverse order, right? So instead of us inferring, or rather knowing, hey, that these sides are parallel, we can say, well, if we know that the sides are proportional, aka we know that the triangles are in fact similar, then those sides, rather I should say the opposite side, has to be parallel to that mid-segment. And so that's what we're looking at there. I'm sorry, I apologize, my fingers kind of murking up my pen there, but let's go ahead, let's take a look at this. So we have this triangle here. Now, we already know, hey, mid-segment is in fact parallel to that bottom side there, or that base. So let's go ahead, let's make up our proportion. So our proportion here, we have our small triangle. So let's go ahead, let's talk about this top side first, I suppose. It doesn't really matter which side you start with. Let's start this top side. So that side is 12, and that's going to be over. So a lot of students trick this up, right? They would just say, okay, the other side's 14. No, the other side's not 14. It is this entire side. So it's 12 and 14. So that entire side is 26. That's something I see students mess up all the time, right? So same thing with this bottom side now, right? So this bottom side here is 15. And then the bottom side of the larger triangle isn't just x, it's x and this side of 15, so that is x plus 15. So x plus 15 here. Bam. So now we need to go ahead, cross multiply. So let's cross multiply here. So let's go ahead and do 12 times x plus 15. That equals 26 times 15. Right, so I'm just doing a little cross multiplying there. Make sure my stuff is staying on screen. I'm going to go ahead and do some multiplication off of my screen now. So let's do 26 times 15. Let's see, that's 390. And then let's go ahead, remember to distribute here, right? So a couple of us had a little bit of trouble with that on our mid-chapter. So let's go ahead, let's clean that up a little bit. So that gives me 12x plus 180. So let's go ahead, let's subtract by 180. So it gives me 12x equals 210. Divide by 12. And that gives me, let me just double check so I'm not guessing, 17.5 there. Let's go ahead. Let's try that one more time. So we have number 2 here. Now notice smaller side now is x, right? That doesn't really change my method here. Let's go ahead. I'm just gonna draw in that smaller triangle so I know, hey, here's my smaller triangle. Now notice we already know, hey, parallel sides here, right? So parallel mid-segment and parallel base. So now let's go ahead and make up our proportions. So let's start with x over this side is x plus 18. So you guys are going to see that a lot this section. So just make sure to watch out for that. Let's see, that's 56 for the smaller triangle, and then for the larger triangle here, I count that as 77. It's getting a little cramped there on that side, so let's go ahead. Let's cross multiply now. I'm going to do that over here. So before I put my pen down, let me show you what I'm going to be putting in my calculator. So we're going to distribute 56 into x plus 18, and then 77 times x, that just gives me 77x. So when we distribute here, that gives me 56x plus 56 times 18. I can't do it in my head, so we're going to type that in. It gives me 1008, and that equals 77x. So now we subtract by 56x, and so that gives me 1008 equals, that would be 21x. Divided by 21, and that gives me 48. So there's my answer there. Now, let's go ahead really quickly. If you guys do want to pause the video, I would like for you guys to try out 3 and 4. They are a little different than what we looked at with 1 and 2. Not that much though, but go ahead and give those a quick try real quick. I'm going to be walking through them, so just go ahead and pause the video real quick. But let's go ahead walk through 3 and 4 now. So let's see here. Now notice for this small triangle right here, right, so this top side right there, that's going to be 55 minus 45, so that bottom side there, small side, excuse me, is going to be 10. So now when I make my proportion, that's going to be 10 over 55. And then that's going to be over x. And then this larger side is x plus 36. So it's x plus 36. I'm getting a little crooked. I'll fix that up a little bit. Can't really fix much. Anyway, let's go ahead, cross multiply. So that gives me 55x equals 10 times quantity x plus 36. So when I distribute, it gives me 55x equals 10x plus 360. Move all your x's to the same side. Gives me 45x equals 360. I'm going to go ahead and divide by 45. I'm going to do that on this side of the paper just so when I cross over here, I can say, hey, x equals, double check with my calculator here, does equal 8. So there's my answer for number 3. Now let's go ahead, let's do the same thing for number 4 here. So again, notice for my smaller triangle, this side is going to be 21. So now when we look here, it's going to be x over x plus 7. And that equals 21 over 27. And let's go ahead, let's cross multiply. So it's 21 over, or excuse me, times the quantity x plus 7, so we're going to distribute that here in a second. 27 times x just gives me 27x. So let's go ahead, let's distribute. Gives me 21x plus, let's see, it's 147 equals 27x. Subtract 21x over, gives me 147 equals 6x. Now from here, we are going to divide by 6. So let's go ahead, I'm just going to plug that in my calculator real quick. So let's see. Alright, let's go ahead from there now, flip that page. So just a couple different questions here. So we are going to see some of these on your homework. So let's go ahead, let's walk through them real quick, and then we will be all done for today. I'm pretty sure this is, in fact, the last page. Yep, so we just have a couple more here. So let's go ahead, let's talk about number 5. So number 5, we're still using this proportionality, or rather these proportion theorems. So from here, we're going to identify, hey, here's my, oh, I did a bad job there. There we go, a little bit better. But here's my smaller triangle. Now for my smaller triangle, let's do 30 over, so this is now x plus 7 plus 30. Well, 30 and 7, that makes 37. So that's why I'm putting x plus 37 on bottom down here. Just something I want to point out there. You can add those numbers together. They're like terms because they don't have a letter attached to either of them. Let's see. We have 25 over 25 and 15. Let's see, that means 30, 40. So let me go ahead, cross multiply here, and it gives me 25 times quantity x plus 37, and that equals 30 times 40. So let's do some quick calculator shenanigans here. Let's see, I also want to do 25 times 37 real quick. There we go. So when I distribute here, it's going to be 25x plus 925, and I already know 30 times 40 is 1200. So let's subtract by 925. It gives me 25x equals 275 divided by 25, and I'm going to get, pretty sure it's 11. Let's double check. Always double check if you're not totally sure, but hey, look at that. X equals 11 is my answer for number 5 there. So let's go ahead, let's just keep going here. If you want to go ahead, pause the video, give number 6 a try. This one's a little bit more tricky just because we have 2 of these now, rather with number 5 we only had 1, but I'm still going to do the same thing. I'm still going to use these proportionality theorems. So if you want to go ahead, maybe pause, give it a try. But from there, let's go ahead, I'm going to walk through it now. So let's see here, we have a small triangle, or I should say our smaller triangle. So for this one, let's do 3x plus 1, and then that is over the larger side. Now this larger side is 3x plus 1 plus x minus 1. So we have multiple like terms here. Not only do we have a 3x and an x here, 3x and x make up 4x, but we also have plus 1 and minus 1. Those do cancel each other out. They equal 0, so I'm just left with 4x as the larger side, the side of the larger triangle now. That is equal to, smaller triangle has the side 21 over, larger side here is 27. So now when we go ahead, cross multiply, so let's see, 4 times 21 is 84, and then we need to go ahead and distribute that 27 into 3x plus 1. So let's do some quick calculator shenanigans here. Always triple check. You can never be too sure. But 81x is what 27 times 3 is. And 27 times 1 is just 27. So now when we move all of our x's to the same side of the equal sign here, it gives me 3x equals 27. And divide by 3. And you get an answer of x equals 9. So again, notice, does it have a little bit of different work? Absolutely. Work looks a little different, but my steps, those haven't changed, right? I'm still setting up the proportions. I'm still cross-multiplying. Now, with number 6, I do have to move my x's to one side of the equal sign, but that's really all that changed from 5 to 6. Now, let's go ahead. Let's talk about number 7. So for number 7 and 8, really, we're just trying to determine if MN is, in fact, parallel to JL. So what we're trying to determine is, hey, are these sides actually proportional? So let's go ahead, let's make our proportion again and to see if those two fractions are in fact equal. So it's going to be 11 over, and then this side's going to be 11 plus 15.4. and that's going to be 26.4. Right? And then that's going to be equal to, let's see, it's going to be 10 over this side is 24. Now, what I would highly recommend is, I'm going to actually do it myself here, but if you do not have Desmos open, go ahead, open up Desmos. Now, what nice thing about Desmos is that it will simplify fractions for you. So, for example, if I type in 11 over, maybe if I type it in right, there we go, 11 over, and I know you can't see this, but I am typing this right into Desmos, so I'm typing 11 divided by 26.4, and then I'm going to hit the little fraction button. That does give me 5 over 12. And then if I do the same thing for 10 over 24, let's see, 10 divided by 24, hit the fraction button, that does give me 5 over 12. So because these are in fact equal, they are the exact same fraction, my answer for number 7 is going to be a yes. Now, for number 8, I'm going to let you guys pause, take a try, right, see if they are in fact proportional. If they are, it's a yes, but if these fractions are anything different, right, if this was like 5 over 13, this would be a no, right? But let's go ahead now, since you guys had a little bit of a second there to pause, let's figure this out. So it is going to be 15 over 19, and then that's going to be 18 over 23. Now, I am going to go ahead, just double check, make sure, but it doesn't really look like, no, doesn't really look like these even simplify at all, so this is, in fact, a no, right? Not equal, those are not the exact same fractions, so that is a no for number 8 there. But let's go ahead really quickly to finish off here. Number 9. Alright, hello everybody, sorry about that. I had a little bit of technical difficulties. I think it's gonna kind of shock me back in there, but let's go ahead, let's really quickly do number 9 here. So I'm gonna go ahead, while I'm reading this, I'm gonna fill in the information they're telling me. So modeling real life on the shoe rack. So here's our shoe rack. BA is 33. Let's see, CB is 27. CD, so that's this one right here. That's 44. And then lastly, DE down here is 25. Now what they're telling me is, or rather what they want me to do is, hey, explain why this shelf right here, so BD, why this shelf isn't parallel to the floor. Well, just kind of looking at it, doesn't really look parallel, but that's not good enough. We got to prove it. So let's go ahead. Let's show that these sides here aren't in fact, or rather are not proportional, right? So what we did with number 8 over here, my notes are over to the side here, but let's go ahead. Let's try this. So it's going to be 27 over, and this side is 60 because it's 27 plus 33. And then over here, let's see, it's going to be 44 over 69. And then let's see, so on my calculator here, so it's going to be 27 over 60, which is 9 over 20. And that's going to be equal to 44 over 69, which doesn't even reduce. So here's what I'm left with. Those are in fact not equal, and so they are in fact not parallel. Right, so there is number 9. That is all I have for you guys today, so please go ahead, log into Big Ideas Math. The homework is live. I made sure to have somebody double check for me. I had somebody log into a student account on Canvas just because I've had so much trouble with Big Ideas Math so far this semester, but there is number 9. Please go ahead, log into Big Ideas Math, get that homework done. It is due this Friday, but go ahead, start working on it now. See you guys.